Welcome to the second lightning talk session, which got lost in translation. We don't actually wish anybody the clap. We're supposed to be thunderbolts and lightning, and we are preparing for TNCs where there will be extra sessions whereupon we will actually do the full lyrics to the song. God, thank you. And probably even, and if that works, we'll do the costumes as well. Oh. God,
we need
tough,
two more.
Tough crowd.
Whoa, you were so good at holding back that word then. Anyway.
Wasn't I just?
Yes. So, I don't know how many we've got here. I think we're down to 15 this time. So this is why you'll have much more Guido and I.
Well, we're down to 15, but we've also got a scoop this time around. The first time somebody's going to try and co-present on a 5-minute slot.
Twice. Yes. So, co-presenters.
Not if we can't stop them, right?
No. Maybe that's why you need two hosts, so you can take out each.
Take out two,
yeah.
Precisely.
Yeah. It'd be like Eurovision, where we'll have to impose a maximum limit of 6 people on stage.
You tackle the big guy.
Okay. So, first up we have Ingrid. You can see the list there, but that's already wrong because 2 people have been added to the program. But Ingrid is up first, talking about exam killers. So, come to the stage. You understand how this works. 5 minutes and it's all over.
And a new clicker. Why is that?
A new clicker. Oh, cool. I'm going to talk about what happens to your network when you add applications who have high requirements for reliability, security, and other nuisance stuff that make you have network people around all the time. In our case, that's digital examination systems, digital assessment systems. And it was fine as long as they were on campus, if they followed all the campus best practices, built the networks according to whatever needs they had. We were okay. They just needed to add a bit of power for all those laptops the students dragged into the examination rooms, and a few applications, but this is okay. But about half, or somewhere between 1/3 and half of the exams are actually held outside campus. Dragging fiber and power supply into sports halls, church basements, parking houses is a major hassle, and we're currently at the stage where we're building ad hoc networks, doing ad hoc power supply, and it's expensive, it's difficult, and we really need to go back to that, sort of the same level of network that we have on campus. The other thing is, bring your own device depends heavily on having wireless access. So for all of Uninet, we've had to add wireless support at the same level as the cabled wired network. This does not come by itself. This is a major undertaking for all the universities, all the colleges in every single building. It's not enough to supply just a big pipe into the university. Our work is not done. So we have to be at Rome everywhere, including the church basements I mentioned earlier. And then the federated login system has run into challenges. It turns out if people are stressed, they tend not to remember their names. They tend not to remember passwords, where they're from, what institution they're at. And also they have gotten used to caching their credentials in browsers and applications. So they're not used to actually inputting username password. And when we start controlling the user interface, the lockdown browser or terminal server or what we use, this is the result. We haven't really crunched the numbers yet, but first indications is around 40% login failure for the examination systems. That's a lot. And it's not because of problems with the federated login, it's between the keyboard and the chair. And then I mentioned bring your own device. Yeah, they do have equipment. Some of it has viruses. Some of it has other stuff. It's a really diverse environment to work in when you do bring your own device for digital exams. And we do have some recommendations on what you should do. Then, of course, you have to monitor all the incidents that crop up, whether it be a pad or a smartwatch or something that starts jamming the Wi-Fi, or someplace in the cloud loop, because most of these systems are placed out in the cloud. So cloud loop surveillance end-to-end, and a lot more monitoring work than we anticipated at first. And this really gets the response teams on their toes. When you have 340 crying engineering students down south in Norway, you run, trust me, you run. You have to have high availability of everything. And if you want to read about this, go to the lower URL there. If you don't read Norwegian, pick the English version. We're in the process of translating, so not all of this is available in English. Not all of the documents are done. Some will come out in August, July, and one in September on integration. So there's a lot of documentation out there. Thank you.
Fantastic. Gorgeous. Thank you very much. Stop that. I'm being timed. Funnily enough, while we challenge everybody to be timed, I don't actually like to be timed.
No.
For the next speaker, somebody who's never worn a tie before and is now wearing a tie, that is how important we are, the good old Dr. Andrew Howard, who has to present his speech without the fantastic technological tools he would like to use, instead is being put on the Procrustean bed of the lightning talks.
Is the clicker?
Yep.
Thank you. I'd like to talk to you about InfiniCortex and InfiniCloud and extending Infiniband to transcontinental distances. The human brain, home to our ideas and dreams, is the most complex of networks, and when connected through the web of the nervous system, surrounded by the cortex, both sides of the brain combine and those dreams and ideas become the spirit and knowledge which defines humanity. National and global science is delivered today by high-performance computing systems with massive data stores connected to each nation's research and education networks at very high speeds. New generations of science and research bring new challenges for combining computation and data distributed around the world in a fast, secure and energy-efficient way. Using the Obsidian Strategic's longbow devices, our teams have extended Infiniband beyond the data centre to intercontinental distances. We created the first extended Infiniband connecting Singapore and Australia via Pacific Northwest Gigapop over a 30,000 kilometre path with a 305 millisecond delay product. The acceleration of data movement was profound. A 289 gig file transferred between Australia and Singapore, which took 3 hours using traditional TCP sync, was reduced to 7 minutes. And a 1.14 terabyte data set, which took 9 hours using traditional TCP sync over a 10 gig network, was reduced to 24 minutes. While we can achieve some of this level of performance using TCP tools, our experience participating in the ESNet Science DMZ and data movement projects have shown significant requirements for tuning every component of the path to achieve data transfers of this volume. We have included this capability into InfiniCloud, our InfiniBand-based cloud, and observed a 10 to 15% overhead for running within a VM, and are working on reducing this overhead using Docker. Infiniband is a new, more efficient network technology already used as the high-speed communication system to connect computers in the data centre. The InfiniCortex is an innovative and pioneering endeavour led by A*STAR to envisage, design and create a national, regional and global InfiniBand fabric linking the high-performance computing and data centres of many nations to enable research at a global scale. Extending InfiniBand to international distances uses around 90% of the high-speed network capability, a 3 times improvement in utilisation over TCP/IP. This new kind of network is called an InfiniBand fabric. Our teams have built and deployed a portfolio of applications which share big data and compute at global scales in a secure and more energy-efficient way. 4 elements align to make this possible, starting with the ACA 100, a high-speed network connecting Asia and America. A challenge was presented by Yves Poppet, about how to utilise this speed in new and innovative ways to accelerate applications. Dr. Marek Mikhailovich of A-Star envisaged creating an InfiniCortex by using the Obsidian Strategic's Longbow Infiniband devices and desync file transfer utility that A-Star and NCI in Australia were jointly evaluating. The InfiniCortex has grown from a Singapore national project in early 2014 to become a regional and global information transport hub. This year has seen an extension to Europe using the TN network to access European facilities in Poland, with additional connections under construction to France, and from the Asia Regional InfiniCortex hub in Singapore, a connection to South Korea. InfiniCloud combines the high-speed communications of the InfiniCortex with today's flexibility of cloud computing. Using Infiniband RDMA allows separation of the computation and data at global distances while still providing access at the highest possible speeds. Building on our capability, our teams have created an InfiniCloud-based genetic sequencing system which uses the high-speed RDMA capability of Infiniband to efficiently and securely transfer large data sets and results. The InfiniCortex links national federations and regional constellations to create a global galaxy of supercomputers, enabling a new scale of science. Efforts of this scale would not be possible without trusted partners, collaborating with teams nationally and around the world. With the help of our valued commercial partners, we have built a platform for the future. This is just a prelude to a presentation that Yves Poppet will be giving later today, and I would encourage you to attend that. Thank you.
Did you just compress 30 minutes into 5? I get the feeling my mind's reeling. That's the first time, I think, where a tape was accelerated and the voice pitch went down. That's new to me. Here is the repeat offending second lightning talk during tnc15 from Brian Nisbet.
And my God, will I offend. So, with apologies to Disney, all of the parents here with small children, and in fact everybody else, do you want to build an NREN? Come on, let's go connect. The students need their data link. It helps them think and gets them on the net. So, NRENs. NRENs are awesome. We all are here, we think NRENs are great, but it's very easy from a European point of view to kind of forget the past. We have federation now and storage, and we have research and collaboration and all these fancy tools, but I remember, I think a lot of people here do, dimly remember the time when bandwidth was a huge problem, when we were struggling to kind of get all that data down very small pipes. Now it's sort of in the past. But that's not the case everywhere. And that's why, and it's been said a few times this week already, we need to spend time on those regions that haven't got the resources we have, that aren't in the position we're in. And that's where things like the BDREN project come from. These are the stats right now for Bangladesh. That's 6 public universities with bandwidths above 50 meg. From a European point of view, wow, how do they even internet? But there was a plan, there was a project, and Professor Javed Khan from Kent State University in the US did a lot of work on this, and other people in Bangladesh, and things are now rolling. So, incredibly difficult country. Geography, it's only twice the size of the Republic of Ireland, but much more challenging geography. Poor service provider infrastructure, poor infrastructure all over the place, unfortunately, and a lot of politics. Unsurprisingly, students in Bangladesh are no different from students anywhere else in the world. They want the internet, they want connectivity, and they want it now. So, what do? First of all, funding. Funding from not only the Bangladeshi government, but also the World Bank put a lot of money into this. That's how we in HEANet got involved, and also ORNet, the Ohio State Regional Network, to give advice, to kind of hopefully avoid some of those pitfalls that were being talked about in the regional international collaboration session yesterday. Then, like all sensible NRENs, you go to your electricity company and say, hey, you've wrapped fiber around wires or slung it underneath, can we use it please? And then you build your office and your data center They have about 300 terabytes of storage there, and they're planning some VN capability quite soon. So the fiber is all there. Unfortunately, it's not lit right now. And unfortunately, this network map is mostly just the plan rather than the reality. The data center and the office exists in Dhaka. They have 14 staff there at present, and I think, if my numbers are correct, and they're planning on recruiting a lot more soon. But the other pieces outside Dhaka, unfortunately, because of some of the problems that the country's been having recently, haven't yet been rolled out. But hopefully it's only a matter of time before all those other pieces and all those other universities go in. So there's a lot of work to do to convince the universities this is the best way of doing things because they're not used to an environment. Then light all that up, connect all those locations, get them to speeds comparable to Europe, the rest of the world, set up communications infrastructures, video conferencing and unified communications. It's very difficult to move around Bangladesh, and these are vital, vital pieces. Train the university IT staff to operate these so they don't need to go back to the NREN every time to ask questions, a huge part of it. And then truly the NREN can start helping educate the current and future generations of Bangladesh. So we've had a number of calls to arms this week already. Here's another one. Again, going on what was talked about in the plenary session, the panel session yesterday afternoon. Listen to these NRENs around the world. There's got to be someone either you know or you have a relationship with. Get involved. Twin with an NREN. Maybe send somebody out for a week or 2 weeks or longer. Set up a mailing list with them as well. A great idea from Dale yesterday, just to have conversation. Talk to your governments to help them. Give them money, give them resources, peer with them, and encourage the telcos in the area to ethically tap those markets and bring more connectivity to places around the world, especially small, kind of slightly awkwardly located countries like Bangladesh. There's a huge amount we can do. We need to push the NREN idea out further around the world, and it's a good thing. Thank you very much.
So Brooke and I have discussed this new rule, whoever sings on stage, 30 seconds extra. Well, I mean, you overwhelmed us. Yeah. Do you reckon there should be a new rule for dancing? Dancing. Nah, let's just keep it.
And just like every good Eurovision entry, costume change would be encouraged.
Not for you, unless you want to. We're putting you on the spot. Tokozani, give it a shot.
Okay, I'm going to talk about disruptive innovations in the NREN community. First of all, disruptive innovation is a concept that was created by Michael Christensen, popularized by his book in 1997, Innovator's Dilemma. And at the time, it was disruptive technology. And then in 2003, upon realizing that this concept of disruption is not only applicable to technologies, but you also find it in a business concept. So in 2003, it was called disruptive innovation instead of disruptive technology. Well, I'll talk about the characteristics. Basically, what happens is disruptive innovation is not targeting the high end of the market. What happens is these companies come in at the low end of the market and they work their way up. You can see with integrated steel companies that have been there for a very long time, and then there's these mini mill companies who are actually coming in at the low end with the reaper, which is concrete reinforcement. Because of their low cost and everything, they came into that market and they took it and they worked their way up. Then you've got the angle bar, because the integrated companies, their cost is high, these guys are coming in at a lower cost. Just to elaborate some more on disruptive innovation, there's a difference. You've got disruptive innovation, which is blue, and then you've got breakthrough innovation and incremental innovations. I won't elaborate on that due to the time, but you can see the difference in terms of the market and in terms of technologies existing and new, but you can speak to me after this. To make this relevant to us, because we are NRENs, I thought SDN would be much more relevant in this particular discussion. There's a paper that was published by Astuto and Gang in 2014 that shows the proposed benefits of SDN. And there they are: centralized control, simplified algorithms, commoditization of hardware, eliminating middle boxes, and enabling design and deployment of third-party applications. Now, if you look at those benefits, they also correspond to certain disruptive innovation characteristics, like your new value propositions, simplified algorithms. For instance, that's a new value proposition in a sense that it will make it easier to develop a lot of applications, real applications, not scripts in the network, that you can use to manage your network, using SDN. And then if you look at just take the infrastructure layer, you look at these network devices. What Astuto said is that these devices will be commoditized. By commoditizing them, we know that a lot more companies will be able to offer these devices. The price will go down, which puts certain companies in an excellent position. I mean, if you look at those guys that are currently offering us generic optics, SFPs, those guys are in the best position to give us these devices. And I won't be surprised if they take advantage of that, or they will be one of the first companies that would make most money from SDN. Do I move on? Okay, antecedents of SDN, what needs to be there? What should you be doing to make sure that the groundwork is there so that you can take advantage of disruptive innovations, not SDN? R&D process industrialization, parallel processing, modularizing product development. And then there's also certain strategies that one can take advantage of, like simplification of your product development, augmentation, that's taking existing products, like your Intel Centrino, for instance. That product, instead of Intel making a faster product, what they did was, there's a market that wants mobility. What can we do to make sure that your laptops can last longer in terms of battery life and all that? So that's how Centrino came into existence. That's augmentation. Exploitation for another application. ABS came from planes. Now it's being used in our cars, miniaturization. And Delphi technique is one of the techniques that we can use to implement and develop disruptive ideas. Thank you. Books you can read.
Fantastic, thank you so much. We really do need to up the ante.
It's a surprise, a quick conclusion, right?
Yeah, indeed, yes.
And
thanks for not going through all the references. Stratos, you ready? Look at that, calmly making an entrance. Not scrambling up the steps, no. Go for it.
Hi, my name is Stratos, I'm from GRNet, and I'm part of a member of the CNFO development team. We are building an open source cloud software which powers Okeanos service, which is run by the GRNet. We have Okeanos Global, which is a service that is available to all the Xiant community. We ran kind of an experiment with PSNC from Poland to assess the viability of a cloud disaster recovery scenario between NRMs, and we want to see the performance of such a simulation or scenario, and to identify some bottlenecks and see what we can do to make it faster or better, and see if it actually works. So we got some physical nodes from GRNet and some from another NRM, PSNC in this case, and we connected those physical nodes with a layer 2 VPN, and we did a replication of the VM disks so that they are highly available between the two data centers, and tried to live migrate and fail over the VMs between those data centers so that in case of a catastrophic failure in one data center, to see if the user will see any service disruption or they will get their VM connectivity up and running very fast. And we also had some private network connectivity between the VMs. That's part of our cloud infrastructure. So the two nodes were provided by JNet and PSNC. The DCs were about 2,000 kilometers apart. We used one VLAN for the physical node connectivity and one VLAN for the VM-to-VM network traffic. We put all the nodes in one cluster, and we spawned some virtual machines on that cluster and tested how we could migrate VMs from one data center to the other without the users noticing it. And all the nodes had gigabit connectivity. It was 4 NICs actually in LACP mode. So some baseline stats. We had 64 milliseconds latency, RTT between the two data centers, and about 200 megabytes physical node to physical node throughput, network throughput. Inside each data center, we had about 100 megabytes per second disk replication throughput. So, and it was the network throughput between the VMs was at line rate inside the data center, and it took us about 20 seconds to live migrate the VMs, one 8 gigabyte RAM VM from inside one data center from a physical node to another. So when we put the replicated disk on a physical node on the Polish data center, we saw that the throughput didn't change that much, but from our experiments, and the results were varying on the throughput depending on the size of the writes. Smaller writes gave us smaller throughput numbers, and the cache settings on the physical nodes and on the hypervisor that we used QEMU. And we got about 10 seconds more to live migrate one 8 gigabyte RAM VM from Greece to Poland. But the network throughput from one VM to another between the two data centers was at line rate. It wasn't affected that much, but the RTT, the latency between the VMs was at 65 milliseconds, which is kind of an issue because the throughput and for a single VM is acceptable, but the latency can be an issue for the replicated disk. And I don't think that there are many applications that can use that kind of latency. It will be affected. And as the VM density on the physical nodes increases, the network latency and the limited throughput can be kind of an issue, so you can run as many VMs as you would like and over-commit your physical servers with more VMs. But the failover case, which is the most common disaster recovery scenario, so that in case of a catastrophic failure in one data center, that you can fail over one VM right away to the other data center, seems to work and is impacted much less by the network throughput and the high network latency for a disk. So what we need to do in the future is to integrate the DR functionality better in Cineflow, because to make this work with our stack, we had to patch things around, so it wasn't very easy. And explore some one replication capabilities of the storage backends, because to explore some eventual consistency capabilities of both DRBD and the other storage backends. Thank you.
Well handled. Does it start?
It's already ticking now, yeah.
Actually, never taken. How does the thing work? Oh, like that. All right.
Good work.
You ready? Do you need an introduction?
Guido only ever drops this. It's an awesome row of Australians, almost on stage.
So this is how these tablets work?
Yeah.
Oh, nice.
Children can do it, apparently. Cats. Yeah. Guido can never touch this. Yeah. Magnets befuddle him.
There. I did it. You ready?
We don't let Guido touch technical stuff at ARNet. G'day, my name is David Wild. I'm from ARNet. I'm the network architect at ARNet. A brief bit of background. So I'm going to be talking about what infrastructure we use to manage our network. We're Australia's academic and research network, and with the increasing number of customers, the expectations are increasingly high on us to reliably manage and monitor our network. We are recruiting, as I said yesterday. If you're a network engineer with coding skills or a coder with network engineering skills, come and talk to me. It's a tough life in a typical ARNet office. So we run a network. It's an underlying optical network which covers the country, and sitting on top of that, then we put routers and switches, several hundred devices into the thousands now. Historically, we used to use 1RU servers dotted all over the place doing individual tasks. They've become, I guess, less and less reliable. That network extends all the way to the west coast of the United States and to Singapore, so we've got quite a large footprint. Now, you get 2 geography lessons today. The first one is that we've just recently relocated Australia. This is so that we get to come to the TNC conference, but more importantly, to take part in the Eurovision Song Contest this year. But no, this gives you a bit of an idea of the size of the geographical area that we're trying to work with here. So what have we done? We've replaced those individual servers by 4 and 8 blade servers, and we've dotted them into each of our backbone sites. And then each of those blade servers has got some storage, and we've put in some centralised storage across 3 sites within Sydney. Your second geography lesson is so that if you come to Australia, you can recognise these different places. Perth is where you get sharks. Adelaide, more sharks. Melbourne, poisonous stonefish. The Tassie tiger down in the south there. Blue-ringed octopus in Sydney, so don't swim there. Funnel-bag sunward spiders, so don't walk there. Snakes, more snakes. Out in Darwin, you get not just jellyfish, but also crocodiles and sharks, so you should probably avoid swimming up there too. And we've extended, or we are extending, that open flow infrastructure out all the way to the United States. So at each of these sites, this is what we're putting in place, a 4 or an 8 blade supermicro server. And then across all of those, so the top layer of orchestration is OpenStack, as I say, and that's common to the whole infrastructure. We use Neutron and OVS for the networking building blocks. Virtualization, we use Red Hat, so KVM, and sitting underneath that there's the centralized Ceph storage in Sydney, but each of those blade servers has got localized storage as well. Just to give you an idea of the scale, right now it's, I think, 17 sites. That's going to be pushed out to 20, so about 100 blades across the whole lot. Each of those blades is connected at 10 gig. About 5,600 cores across all of the sites there. The local storage split across those 20 sites is about 0.5 petabyte, and the centralized Ceph storage, about 700 terabytes right now. What do we use it for? Well, an example of this is Netflow data processing. We do a lot with Netflow for billing and other visualizations. So our routers export flows to VMs, and that stores temporarily the data in local storage there, and then we can fire up other VMs depending on the load to do processing of that, and then that'll be stored into that central store, so we've then got visibility in one place for visualization and analytics. A second example, we've deployed Ookla speed test servers into each of our capital cities, and therefore we can boast to our friends that we've got better internet connection than that is in fact 1.5 gig in and out of one of these speed test servers. So where to from here? Well, my colleague David Jericho, who's been primary in building this, noticed that based on the number of cores, we're actually in the top 500 supercomputer list. And I think he has plans on working his way up that list. But more seriously, I guess we can use this infrastructure for a whole range of compute-type tasks to go with the storage which we also have for providing to researchers. I'm very sorry, Guido and Brooke, but I finished early. Obviously, I talked a bit too hard. If you have any questions, there's my details. Feel free to contact me and I'll...
First lightning talk to actually take questions from the audience. Quickly. No questions. That's a relief. Thank you. What an excellent talk, by the way. That sounds like just the NREN to work for it.
Apparently recruiting, right? Recruiting. Except part of the induction should be to spot the difference between thylacine Tasmanian tiger and Tasmanian devil, which was actually on the slide. Tassie still doesn't have 100 gig hassle, David.
God, we all care.
Tasmanians do.
Yes.
That's me. Now we have our first, well actually it's not really our first double act, but it's our first double act as a talk. So here they are.
Our first double act, you have 5 minutes to do it.
Thank you. Get rid of my 5 minutes, please. Thank you. I'm Linus, this is Magnus. We come in peace. We also come from Norgenet and KTH. We're going to talk to you about something called Cattlefish. How many of you have heard of certificate transparency? Anyone? 1, 2, 3, 4. Oh, great. This is like 10 people. This is going to be good. Is this forward? Okay. So what are we trying to solve? SSL is used for your browser to be able to find which public key is associated with, for example, login.trina.org. And then it will show you this padlock, which shows that you're on the right place and that you are encrypting in the key that the site owner actually has control of. Right. This is done by a certificate authority, which guarantees by issuing a certificate that this key is actually tied to this name. The problem is it's hard to keep keys safe and secure. So occasionally they get stolen and someone issues a certificate that they shouldn't, or someone fools the CA into signing something that they shouldn't. Or the CA just doesn't follow the procedures. Maybe they go bad, or maybe they are just not, doing what we think they should. So how can we help this anyway?
So let's just save all this in a public log, right? Because then all the domain owners can just search through this data and see if they find anything that's signed that shouldn't have been signed, right? That's no problem, or?
Sounds like a good idea, but I mean, if someone has stolen the key from the CA, why couldn't they steal the key from your log and just remove that entry that is the offending one? And how could you then find out that someone issued a certificate for your site?
Well, then we'll add some more things. Then. We'll add auditors that check this log, and in a cryptographically secure and efficient manner, bandwidth and CPU-wise, just check if the log actually is append only. And there is actually a description of this in RFC 6962. So let's just use that, right?
Okay, wouldn't it be bad if we had one single implementation and one single large operator? I mean, who would be doing the auditing? Who would be doing all these things? Shouldn't this be like, diversified in some manner?
So that is why Sean in the Gen 3 Plus project has actually made an implementation, or we have made an implementation in that project. And this implementation is really not maybe made for, but very suited for the NRAN community, because it's constructed in a way where you could actually use this system in a secure way across multiple organizations. So not only can you have one organization run this securely, but you can have it spread out over different organizations and you still don't have a security problem. So please run a part of a log.
Yeah, and now we have 1 minute for questions.
And please go to our website and go to the poster session where we can describe more.
We have a poster downstairs and we can discuss the technical details there, because this is not the time for that.
Fabulous. Yep. And that's an excellent opportunity to remind everybody that there are lots of poster sessions, and the afternoon coffee break they'll be, manned is the word, but maybe we don't call it that anymore. Attended.
You got more time.
Oh, we've got more stuff. Demonstrations during lunch and the afternoon coffee break. Feedback. Fill in the app. We usually rate reasonably well, hopefully because we encourage people to fill in their feedback. And you can do it for the whole session as well as for individual presentations. The gala dinner. Buses leaving at 7:15 from out the back of the building. Where's the back of the building? That away?
They'll depart
The
from
pier side.
The piers, I'm pretty sure, is over there.
Is it?
Yeah, well, that's where the river is, so.
Okay, we'll go that way. So the back of the building.
Now, if you sing this, you get 30 seconds extra.
No. We're starting half an hour later tomorrow, because presumably you'll have some port tonight. Oh, and yeah, there's this car museum. You know when you sort of go up the stairwell and there's a whole floor that you ignore? You don't have to ignore that floor. There's a car museum there, and there's stuff to see. It's kind of interesting. So on your way to lunch, spend some time.
Perfect. Well done, I would say.
Is that about it? We got more people, right?
It is. We got more speakers.
Dave Wilson!
Indeed.
Wow. How to fix Wi-Fi from Dave. And as a reminder, to me and everyone else, stand close to the microphone so we can hear you.
A client spoke to me at our conference a while ago and said, I have no way to see the performance of the Wi-Fi in our lecture theatres. If someone goes to the help desk and says, hello help desk, I'm having trouble with the Wi-Fi in lecture theatre C, step 1 is to wait until everyone clears out of the room and send someone to test it, and step 2 is to give up. There has to be a better way. I'm Dave Wilson. This is How to Fix Wi-Fi with Crowdsourcing, a GN4 activity. Usually, when people think of testing the network, they think of probes. And they're very good because you get objective measurements and they're very reliable. But they have drawbacks. You have the installation cost, including the power and cabling of keeping them there, and you're not seeing exactly what the user sees. So we think probes are great. We need probes, but it'd be nice to try something else in parallel. The kind of questions we'd like to answer are things like, in this room, has performance changed over time? Is it just 3 o'clock? Is this something to do with the room, or is it the user's device? And what do we need for capacity planning? Now, Jeff Houston from APNIC and his team do measurements in browsers. And the way they do measurements in browsers is they take out ads from Google, and the ads are actually flash programs that check your DNS and your IPv6. Basically, they crowdsource results from users' browsers. The data that you get is noisy, but if you get enough of it, that's okay. And we're thinking, instead of worldwide, can we make this work inside a campus or inside a room, inside the browser? What we need is these 3 things: how good your performance is, where you're connected, and what time is it. There are JavaScript tools for doing this, but you can't get Ethernet details from inside the browser. It doesn't work, it won't let you. However, we've radius information as well, and with that we can go from an IP address to an access point, and that's enough, in theory. The question is, how do we try this out? There's a lot of leaps of faith in what I just described. You know, can we get the information we need? Is the data going to be any good? What we really need is somewhere to try it out, and we need somewhere with like a few hundred users in a lecture-like environment, and they're all visiting the same website over a matter of a number of days. Where on earth might we find something like that? So I mailed Dick and Christian last week, and I said, I have some JavaScript. Could you put it on your website, please? And they said, yes. And I emailed Pedro last week and I said, can I analyze your radius logs, please? And he said yes. Ladies and gentlemen, I have something to tell you. If you've been using EduRoam in this building, and you've been visiting the TNC website, you've been helping us to performance test this network, and I'd just like to show you the results. This is the download speed that we measured in kilobytes a second for every test we had until 4 o'clock yesterday for our test file, every time someone hit the TNC website from EduRoam here. And not only that, but we can separate it by access point as well. An example, here's this very room, the plenary room on Monday and Tuesday. You can see very clearly it was empty overnight. This one's fun. This is the poster area downstairs on Monday, and it looks pretty sparse until you notice when the breaks were between the sessions. And as well as download speed, we're also getting a latency measure. So that's room C. Why the big gap at the bottom of the screen there? Well, our server that hosts the tests is in Athens, and that's the round trip time between here and Athens. Barring that, it actually looks pretty healthy. Almost everyone is in like the same 10 millisecond range there, unlike in the plenary room. What on earth is this? This is one user with a 2.5 second latency. Now I checked and they tried again immediately and they got 58 milliseconds, so that was transient. But if we saw a line of these, we'd know that either there's a problem in the room or a problem with their device, and we'd be able to tell which. We can break it down by browser. This is Mac versus Windows, and I tried to do Android versus iOS, but apparently there's only 3 Android people on the internet right now, so you know, what can you do? So what have we learned from this? Well, the first one is, don't know 2 versions of jQuery on the same page. I'm really sorry, Michael Nolan. But also, the error bars in these tests are very wide, and I think they're very wide because we were very conservative about the load we wanted to cause by running the test. We got very accurate results on our desktops with a higher load, but we didn't want to do that here because we weren't sure how it would turn out. I think it's clear we could do that. Most importantly, though, this project began a matter of weeks ago. And instead of sitting down and very carefully specifying over months, we just wanted to try something, see if we can make it work, and drop it if it doesn't. The data you've seen just now, it looks very pretty, but now we're 6 weeks into our GN4 activity, and we have real data from a real network that will shape the rest of our work, and I am thrilled about this. If you have ideas on how to use that data, please contact me. I'd like to thank everyone here for all the help they gave, which was a bunch of work, and thank you very much for listening.
Wow, I guess I'm pretty thrilled as well. That was good stuff.
We actually have a Dave Wilson rule for our selection at the Lightning Talks. Dave actually delivered our first Lightning Talk ever, and it was under 5 minutes, and it was excellent. And so every time Dave says, "Can I speak?" the answer is always yes. So it's a special rule. So unfortunately, if you miss out on giving a lightning talk, it could be because Dave has come up with an idea.
It's like make use of this rule. Be Dave Wilson.
Be Dave Wilson. Yeah. No.
Sorry. Yeah. Yeah.
Okay.
Well, I mean, you're using it.
We have a dress code.
Don't complain.
Alrighty. Next up, Steve Wolf. Some of you might know him. If you don't, visit Wikipedia.
Precisely, the man who does not need a photograph.
How do you advance these things? Just push on the...
Yeah, the clicky here.
Oh, the clicky there, okay. So, what in the hell is a cyber... something entirely different. What's a cyber practitioner? No, push the wrong thing. What am I supposed to push? No, that was not it. A little technical help here, please.
This is forward.
Which one?
This one.
No, okay. So, well, folks like this are typically found around research computing centers, and they go by various names, but if you are a researcher and you've been computing on the campus cluster and you have outgrown that campus cluster, the good news is that you've gotten some time on a supercomputer somewhere. The bad news is that that supercomputer has an entirely different architecture from what you've been computing on. These are the folks you go to say, which of my 2 million lines of code have to be changed to run on this new computer? So what's new in this field is that computational scholarship has gotten a lot different. You don't just have to be an expert in high-performance computing. You have to know something about data center architectures and file storage. You have to know details about networks as well. How do you program the internet to AL2S in order to connect together my 3 data centers and my supercomputer that are scattered across 4 states? So life has gotten a lot more complicated in this business. And the organization of people like this varies from place to place. In Japan, for example, they have a national resource of 30 folk who help out users of the Japanese high-performance computing infrastructure. Here in Europe, I gather in the PRACE community that things are much more dispersed and much more localized. In the US, it's the same way. There are a couple of programs, the ACI refs and the Exceed Campus Champions, who are trying to get organized. But what's the problem here? The problem is that it's not that these folks have no role in academic governance. They do have a role. It's exactly the same as the role of the groundskeepers and the janitors. They generally have no recognized credentials. Just because you have a PhD in computational fluid dynamics doesn't mean that you're a good user consultant. There's no generally accepted career path. You know, if you're a faculty in the US, you're assistant professor, associate professor, full professor. Everybody understands that. There's no such career path in this field. And worst of all, there's no job security. While many of these people are supported as regular staff at universities and at supercomputer centers, I think the majority of them are on research contracts. And if the research contract terminates and is not renewed, these folks are out of a job. You know? There's no severance pay. There's no continued medical care. There's nothing. They're out on the street. Moreover, bad from the academic standpoint, good from the profession standpoint, there's increasing competition from private industry. Big pharma, petroleum, financial houses are all looking for skilled people like this. And so somebody in this situation, in an academic environment, has got to consider whether they really want to give up the academic freedom in return for a real employment contract and maybe doubling or even tripling their salary. Tough choice. This issue has begun to, in fact, even the national labs at the US and the Department of Energy Advanced Scientific Computing Advisory Committee instituted a study of this, workforce development study, the details of which I have yet to see. So why am I here? Well, the Cyber Practitioner Program is something we started to try to elevate the stature of this occupation to a profession. And the reason that I'm here is to identify collaborators, those who are interested in this particular problem and would like to talk with us, to uncover current practice in the German community. For example, I know that there's a very extensive training program at Stuttgart. I'd like to know what else is going on in Europe in this regard. So anyway, this is a joint project of Jim Bottom and myself. Jim's been around supercomputing as long as I've been around networking. So right, either one of us, we'd be happy to hear from you. Thanks very much.
And if you didn't manage to capture those contact details on the screen, you can always visit the website, help Dave Wilson's performance testing project, and look at all of the slides that the speakers have used to present so far today. And eventually, there'll be an archived stream so you can watch it again and again and again because you love us so much. And because you love us, you should rate us on the app. But now we have our second double act for the day.
It's a trend. It might become the new trend. Of course, if you sing.
Not yet. At the end. So, good morning. My name is Niklas from Belnet, and today, in collaboration with Maurice from SurfNet, we would like to make a call for collaboration. You already know eduroam, and as far as I can see, you are massively using it right now also. We would like to introduce you to govroam. So what is govroam? Govroam is a bit the equivalent of eduroam, but that would be dedicated to government institutions, public services, administration, and so on and so on. Of course, all of this will be based on the knowledge that we have already with eduroam. So, currently, govroam is more, I would say, in-country initiative. So, Arnes started using govroam already 5 years ago, and almost all the governmental institutions are connected, are having govroam. Within Belnet, we started 2 years ago, and currently we are working with, dealing with agreements in order to deploy govroam in other federal institutions. And SurfNet via Stichting govroam is actually working on this already a bit more than a year ago, and they are massively investing time in order to deploy govroam within the country. So we don't know, maybe there are other institutions also having a govroam initiative, but so far that's who we know. Okay. Yeah.
Well, you might maybe wonder if you are an NRN, why you should do something with govroam, because Belnet and ook Arnes, they are responsible for governmental things, but SurfNet isn't. However, SurfNet doesn't have time, doesn't have resources to spend on governmental services, but it really is proud on eduroam, of course, and it wants especially the government to use this technique as well. So we started the spin-off. And this spin-off, we started this in December last year, and this spin-off is already taking off big because the people you see here, and in the middle is Erwin Bleuming, the CEO of SurfNet, very proud. But the other persons there, they are paying for this service already. So the foundation of govroam in the Netherlands is already taking off and is paid by all these members, local governments, county governments, central governments, and also the support institutes of the governments. They are already paying for this service. So this concept is really, we find a lot of enthusiasm inside of the government to use this, but they need a little bit of help, and that's why the NRNs should work together, and not only in the Netherlands, not only in Belgium, and not only in Slovenia, but all over the world, of course. And that's why we started to work together. Belgium and Netherlands are very close to each other, and the people from Belgium, they roam to the Netherlands and vice versa, go to Brussels from the Netherlands. So we want people to, who have a govroam account also be online in Brussels, and people from Brussels be online in Den Haag, where the ministerial departments are. So we wanted to work together. The foundation GovROM, not SurfNet, agrees together with Belnet to work internationally together. And the connection already has been established for the radio service, so actually it works in practice right now. Most important is that we, in the Netherlands, in Belgium, but also everywhere in the world, we use one brand. We communicate one message, and we have one community. And that's, in the end, where we will be all proud of as, well, EduRoam community. We will be proud of our younger sister, GovROam. So that's why we call here for your enthusiasm as well in your country, and hopefully you will find a way to start up a GovROam initiative on your side. And please contact us so that we can work together and perhaps make this just as successfully as EduRoam already is. Thank you very much.
It's just disappointing that Rock wasn't here and you could have had 3 people on stage. But that will be a challenge for a future... I didn't talk to the next person. Oh, yeah. That's because you were sitting right next to me. Mark O'Leary is up next.
You missed Mark.
What?
You missed him.
I missed him.
Yeah.
Yes.
Be more conspicuous.
I'm easy to miss.
Off you go.
Hello, everybody. I'm standing in today for Frans Panken, who led the Meal Project. If he were here speaking to you, he would tell you all about the fantastic success we've enjoyed, the future prospects of this work, and how we've got the CEO Forum interested in employing MNCs, etc. But you have me, and I'm going to suppress my normally sunny disposition and try to lift the lid on some of the other things that go on in delivering some of these projects we do. I've been thinking through the conference today, probably heard about 30, 40 projects so far. There will be more that go on through the course of the conference, and they've all been successes and nothing has ever gone wrong. Is that really true, or are some of our presentations skirting around the truth lightly? So take this as a bit of a cautionary tale, and I'll try to be a bit honest about one of these projects. So yes, we obviously had some goals with this work, and we bid against open call funding within GN3+, networking without borders, all very worthy stuff. So thank you, European taxpayers, for setting us working. A little bit about the technology, but this isn't a technology talk. The MEAL project, MEAL stands for Multi-Domain EduRoam across LGE. So it's basically extending some of the ideas of EduRoam to a 4G environment, and your device, the SIM authenticates to the telephony provider network. Then there's a secondary authorization step back to your home organization on your MREN network that then permits you to pass data, and that data is tunneled onto the NREN rather than going direct to the internet from your telephony provider. Very simple, clean idea, the inspiration of a second, I imagine. Obviously, the name of the project had multi-domain in it, so you obviously had to address the case of roaming to another nation, where you would visit an LTE network which would have a roaming agreement with your home telephony provider, and you do the similar authorization step internationally, and then we were hoping to explore whether you then deliver the academic user's traffic onto the visited MREN network for its general access, or tunnel it all the way back home internationally for access from there. Really good design for a project. But it wasn't without issues, and I think that's the real point of this talk. Firstly, I strongly recommend to all of you, if you're organizing a really good technology project, make sure that the partner of one of your key staff doesn't get her dream job within weeks of starting, and your key person therefore has to relocate to a different city and hands in their notice about a month into the project. And you then enter a recruitment phase, and you're trying to find a replacement member of staff and lose about 6 months of progress. And then also make sure that you can find partners that want to be involved when they realize that you actually want to cannibalize their business, reduce their income, and provide a cheap stroke free way of getting international roaming without excess roaming charges. So what actually happened with the project? Well, SurfNet, Franz and Co, and ourselves at JISC, we both successfully deployed the national demonstrator networks, but we didn't achieve that at the same time. While I was hunting for members of staff to do the work, Franz had a fantastically working network. When I had a team that was able to deploy the network in partnership with a provider, Franz's partner had pulled out, having realized that they were really working against their own self-interest. So we never quite demonstrated international roaming. Trouble is, most of these projects, you need hours of discussion to come up with the idea, maybe weeks for deployment, but the actual months of getting things done, the year-long grants that were awarded, are due to the fact that there are problems along the way. We found our main problem: telephony operators don't want to deal with education in many contexts where it starts to look like becoming a competition or forcing them to collaborate with competitors of their own. So advice from this: always have a plan B and a plan C. If you don't reach the full goals, make the most of what you can do. And if there are any Australian network engineers out there looking for a job, please get in touch.
Brilliant. Do they have to be competent network engineers? Tough.
We've got a huge amount of time.
Would you like a new rule when negativity gets promoted with 30 extra seconds? Sung negativity, an extra minute?
No, but I think we should try to.
It wasn't negativity. I mean, it's just sort of constructive.
I think we should accept more full papers though into the lightning talk session. Because I think there's a few too many people that are keeping the time. So I think
he was warning us about declaring success and moving on.
We should have. That was your air sandwich stuff, right?
Yeah, it is. Yes.
Yeah. We should have asked Andrew Howard just to do his full presentation.
He did.
Yeah, he did. Yes. Anyway, we're way ahead of time. Apologies for boring you now. We have Lucas up next.
So take your time.
Yeah.
Shuffle up the stage. Thank you. He's got gear, a show and tell. Oh, another new one. It's gorgeous. Give away a good hand.
So hello everyone. Thanks for the floor, guys. I'm Lucas from CESNET, and I will be telling something different than the previous speakers. I will be telling something about hardware acceleration, because often hardware is neglected. In this software-defined world, you have applications that run in the software, and always they say only, yeah, it will work with the hardware. But no one is actually paying attention to the hardware. We do. We do hardware that works on high bandwidth networks. Currently, we have a 100 gigabit Ethernet card, and we are preparing for 100 gigabit Ethernet card. The 100 gigabit Ethernet card, I have one with me here, if it's seen, yeah. It's a 100 gigabit Ethernet card for standard server. You can plug it in through PCI Express, and it has a CFP2 optical module for 100 gigabit Ethernet of different kinds. It has a Virtex 7 FPGA, so you can program your application on the card. And through PCI Express generation 3 times 16, it is capable of delivering full 100 gigabits per second from the network to the computer, to your server. It has some other features. If you're more interested in this card, I will have a demo downstairs in the demo area after this session during lunch, so you're welcome to visit and ask. Also, we do some research with this card. The demo will show the first point. So packet capture. You can do packet generation also. This is like a basic stuff you can do with your network interface card. So this card is capable of this at 100 gigabits per second. Something more interesting from our research, we usually do monitoring. So we have monitoring up to application layer, so up to layer 7. We use this card to do this. We have a publication about how we do it. Basically, we have a software application that do the analysis up to layer 7, and we have a card that is capable of packet monitoring up to layer 4, and the application can offload the processing to the card, so the application don't need to process all the packets from the network, only the interesting ones. And this way we can accelerate the performance of the application. We also do filtering in the similar manner. So again, we have this card and collaboration of software with the hardware acceleration. Here are some results. For example, if you need to process the full load of the network depicted by the black line, you don't need to process it all in the software. The card can help you, and you need to process only like 1/5 of the incoming traffic on the CPU, so the CPU has more time to do more precise analysis and dig deeper into the packets. What we are starting right now is intelligent DDoS detection or protection of high-speed networks. Or if you have any other ideas, we are open for collaboration. Just let us know. We have access to real network data. We have access to high-speed cards, high-speed networks, so we can test your idea on the real data, on the real backbone network. If you're interested in the monitoring part, I can give you hints about our publications, either Infocom publication or article in IEEE Transactions on Computers about what I do. And that's all for me. So if you're interested, go visit me downstairs to the demo area, or I have a poster in the poster session, so you're invited. Thank you.
It's fabulous. I love how you guys can't stop yourself but have to build stuff. The Bob the Builder song would have been good, though. But otherwise, great job. Everybody talks about hardware. You guys just build it. The bit where you went, like, we have access to cards. What you meant is we'll build them when you call us, right? Yeah. Fantastic people.
That's an efficient delivery program, right? You don't want to have too much warehousing of your cards.
Just in time, yeah.
Yeah.
We're not all as slack as we are.
Yeah.
Well, I guess we are, yeah. We are, but they aren't.
Oh.
Stop it. Brian?
Yeah.
Brian Tierney, people.
Okay. And yep, this arrow one does it?
That's how it works.
That's how it works. Okay. Hi, everybody. I'm Brian Tierney from ESNet and Berkeley National Lab. This is work done with Michael Smitasen as well from Berkeley National Lab. And the problem we're trying to address here is hopefully everybody knows that TCP is actually quite sensitive to a very small amount of packet loss. Here's some results from a few years ago, actually. We had a line card that was dropping 0.0046% of the packets. 1 out of every 22,000 packets was getting dropped. And we ran tests between a number of our perf sonar nodes to see the impact of that. And as you can see, that level of packet loss on, if it's just a few milliseconds away, it's not a big deal. But the longer the latency is, the more impact that very, very small amount of packet loss has on TCP. So we spent a lot of time trying to find the source of packet loss. And one of them that we find over and over again is actually switches and routers that don't have enough buffer space. A really common situation is you'll have congestion at the egress port. If you have 2 10 gig hosts plugged into the same switch with just a single 10 gig uplink, and there's any traffic between this host and this host, for example, it's going to compete against this host and this host. And depending on how the router deals with that congestion and these micro bursts of congestion, TCP will lose packets. So we find that having the right amount of buffering on that egress port makes a huge difference. So to verify this, we set up a simulated environment where we run some consistent background traffic from host 1 to host 2, just a steady state, 2 gigs of UDP traffic, and then we run some TCP traffic on this one to compete with it and see what the impact is. So those are the commands used to simulate latency with TC. Here's the commands used to run the tests. iPerf3 results. We like iPerf3 over iPerf2 because it shows us the TCP retransmits. Going to have to go through this very quickly. I have a lot of slides. But here's the important results, that different switches with different buffer configs, you'll see the big difference in total TCP throughput and the number of retransmits, whereas the sweet spot seems to be you need about 64 megabytes of buffer per port. And particularly an interesting one is the Brocade, which out of the box, by default, the MLXE configures it to just 1 megabyte of port buffer. Whereas if you go in and change the defaults, you will triple your throughput. And we experimented with different buffer sizes on that Brocade because it's easy to change it. And you can see that you need basically 32 to get decent and 64 to get optimal. So that's the magic number you want to be thinking about. Unfortunately, a whole lot of devices only come with 9 megs of per port buffering, and you're just going to be in trouble if you have one of those cheaper devices. Does this work in the real world as well? The answer is yes. We wanted to make sure that wasn't something peculiar to our simulated world with NetM, and so we ran some tests between Brookhaven, New York and Berkeley, California, and basically confirmed the exact same thing. In this case, it was a Juniper. Juniper doesn't let you set the per port buffers in terms of bytes. It lets you set it in terms of a percentage. But it turns out that 20% on an MX80, 30% is right around 64 megabytes as well. And again, this is a slightly longer path, so the difference is even more dramatic. So, a factor of 7 between small buffers and properly sized buffers. One other thing we figured out is there a way to actually measure this? Is there a tool that you can try to detect? Is there a device in my path that doesn't have enough buffer space for me? And it appears that the NUTTCP tool, which comes out of NASA, has a mode that's pretty good at this. You can send UDP packets at a rate of 300 megabits per second in bursts of N packets. So we ran some tests with small bursts, like say 65 packets, versus a large burst of 300 packets. And this one runs clean. This one shows some loss if you have a small buffered switch in your paths. So it appears that actually is a pretty good way to determine whether there's something in your path with small buffers. So in summary, make sure your switches have 32 megs of buffering, and try this out before you buy anything. There's some more information if you want to get into the details.
Wow. Config stuff, right? Defaults are not the best.
Yeah, and I spotted a couple of switches that I recognize there. Tells me something about my past, unfortunately.
They're the ones that Dave is deploying in Tassie.
Oh. Hans, you ready?
Yeah. So I'm going to talk a bit about our efforts to do denial of service mitigation with OpenFlow and something we're developing at IU called SciPass. So we're looking at trying to do this at 100 gig. We want to detect it automatically and block it automatically, and we want to stop it in the wide area network before it gets to the edge, and we want to stop it as specifically as possible so that we don't impede any good traffic. So intrusion detection system, right now we're looking at using Bro. It will allow for deep packet inspection, and it looks for known traffic patterns and will signal our application called SciPass. So SciPass was developed by us at IU. It gives us a IDS cluster load balancing and allows for white and black listing. I'll show you a picture of it here in a minute. And it was primarily designed for Science DMZ. So there's what it looks like normally. You've got an OpenFlow switch in the middle of your traffic, maybe shunting traffic through your firewall. and all the traffic is load balanced to an IDS, and it's looking for a specific pattern. When it sees that specific pattern, it will basically build an open flow fast lane for that traffic. And that reduces load on your firewall and will allow your research traffic to go much faster. So I liked the blacklist feature when they were developing this. This allowed us to match on all sorts of different things and match very specifically. And so what we do with that is it's about the same thing. All our traffic is flowing through. The open flow switch has rules to look at the traffic coming from a specific port and send it over to your IDS. And then it inserts a rule to block whatever the DDoS signature is. And then, so our path forward now is to build it in the lab and see just how many IDSs it takes to look at a 100 gig line rate. Whether it's 2 or 100, we don't know yet. And eventually, we will deploy it in the field. So that was quick, but check us out. Check out SciPass, it's really neat, and check our group out. Thank you.
Going to have to start imposing a minimum slide count as well now. This is our last speaker. I'll let him talk and then I'll come back and annoy you more.
Don't be afraid of going over time. We've never said this before.
Okay, so I got the 15 minutes?
If you wish, the people might disappear. But
yeah. Ladies and gentlemen, my name is Sven Stauber. I'm working for Switch, the Swiss NREN. I do realize that this is the last talk just before lunch. I nevertheless hope that I get your attention. So, ladies and gentlemen, a year ago, I was standing here in front of you. Well, not literally. It was in Dublin, TNC 2014, and had a lightning talk. This talk essentially concluded with this slide. So that's the last year's lightning talk. Matterhorn is a mountain too. Essentially, we have announced our commitment to an open source product that we would deploy and use in production. The product is OpenCast Matterhorn. And of course, if you ever worked in such a community-driven open source product, I mean, the basic idea behind this is that you don't build the stuff yourself, but you hope that you actually have others that join the community and that together you could achieve more. That's kind of the promise of all this. And the bad thing about having a follow-up talk now is, well, that was 1 year ago, so if you paid attention, well, can we really achieve more together? And in this talk, I would actually like to outline some collaboration that actually happened in this OpenCast community where Switch was involved. So yes, we can. Obviously, I mean, the title of the talk is the OpenCast opportunity, so you're still free to join the community. But before I dive into this, I would actually like to ask you, who in this audience does know what OpenCast Matterhorn is about? So 3, 4, well, okay, at least some. So to give you just a glimpse of an idea, it's essentially an open source lecture capture and video management system. Note, by the way, that it's currently being rebranded, so OpenCast Matterhorn will be just OpenCast quite soon. There will be a new release. Well, it was scheduled for this Monday, so June 15, but it's not out yet. I think it will come out in a week or something. And they will also rebrand the whole websites, all that, quite soon. So the key message of this slide is the word that is underlined. So if you are interested in the topic of video, be it video capturing, video streaming, video management, video whatsoever, this can be an interesting product, maybe. And at this point, I would like to note that I will be at the gala dinner this evening I will look like this. So not sure whether this is smart and or geeky, but it's my interpretation of smart, geek, casual, whatever. So let's show it. So, do I get some additional time? Well, already happened. No, seriously, I mean, if you're interested in the topic of video, please find me, look like that, at the gala dinner this evening. Don't worry, it's not our product, so I won't try to sell it to you, so you can just ask, and even if you don't want to use it too, it's fine for me. And by the way, as for today, I have not yet beaten someone, yet. So don't be shy, talk to me. Here's some collaboration examples. So we started using OpenCast more than a year ago, and in the last, let's say, 18 months, some collaboration actually happened. The interesting stuff here on this slide is really just the green stuff, so who collaborated with whom. One of the bigger projects, so this is about more than 3 years of development, so it's quite a big thing here, was a new user interface. So when we first had a look, how much time do I get? Take a little. 2 minutes, huh? When I first had a look at this OpenCast stuff, we were not happy with the interface it had, and fortunately some other fortunately, some other institutions were already working at the new implementation. So this was a quite big project funded by 4 parties, so switch 3 others. Just to give you an impression how OpenCast 2.0 released in a week or something will look like. It's not about details, just an impression. So if you're looking at OpenCast and it does not look like that, you're looking actually at an outdated version. Another example of a collaboration is Stream Security. It's essentially about securing downloads and streaming of video. It's a collaboration initiated by University of Ulm in Germany. Just to give you a rough idea, so there are people collaborating. The most recent example is a technology stack upgrade. That's a very interesting example because everybody hates maintenance. I mean, there's no additional user value, so who would invest? This is a $50K effort to actually upgrade all the libraries and software that has been used over years. And the interesting thing is that 11 institutions from 6 countries have kind of funded these $50K together. And we, for example, we paid $5K or something. That's quite nice if you get so much for so less. And we even feel good about it because we helped to make it possible. So it's a win-win situation for all. Yes, we can. Yes, I will be at the gala dinner this evening, so please meet me. To give you an idea, OpenCast 2.0 will be released soon. Thank you very much for your attention.
I think that the runway show there was very close to at least a wardrobe change from your revision. So,
and he did the dance routine out of that. What's that Tasmanian song?
Yes.
Sorry.
There's a particularly Tasmanian song. Anyway, the demo sessions. There's demo sessions starting in 5 minutes for those interested in field programmable gate array, 100 gigabit a second networking, something or other. Check the program for more info. Lunch, you can get down there, eat. A gala dinner tonight. Check the website for details of the buses. Fill in your feedback forms, and that's all we have to say to you. Thanks for turning up.
Thanks to all the speakers.